So firstly, let's learn the definition of Internet of Things. The Internet of Things is a network of physical objects. So you know what is network, right? Each and every device is connected to each other, and like that, if it is like that, we call it as network. So here it is the network of the physical objects. That is the first sentence that you have to keep in your mind. That is, IoT is the network of physical objects or things embedded with electronics, software, sensors, and connectivity. Connectivity is the important word. So all this physical objects are embedded. Okay, embedded with electronics, software, sensors, and everything, and connectivity to achieve, to enable it to achieve greater value by embedding it with sensors. When the physical object like watch is embedded with sensors or other connectivity and everything, it achieve the greater value and service. Okay, it achieve the greater value and service. Let's assume a fridge, okay, as an example. So here there are embedded inside that physical object, there is an embedded form of sensors and other connectivities. Like if we are using a smart fridge, we will be having internet over it, so IoT connectivity. Internet connectivity will be there, and other softwares and sensors will be there. So everything is there, and as because it is different from the normal fridge, it is having a greater value, right? And that is and that service that you know and that greater value and service is exchanged, okay, to the manufacturer. So we are exchanging the data to the manufacturer. For example, if there is any problem with the cooler in the fridge, it will inform or exchange the data to the manufacturer that there is some problem in the fridge, please come and do such and such things in order to keep the fridge okay. So here it's like calling it's exchanging the data to operator or other connected devices, etc. Each thing is uniquely identifiable through its embedded computing system. That means inside it there will be a computer. In an IoT system there will be a computer which will be having a MAC address and IP address, that is, they are uniquely identifiable. And uh, and if we say about a phone and everything, they will not use, if we are using a fridge, it will not use an extra another kind of internet, it will use the existing internet infrastructure. So this is the definition of the IoT. That is, Internet of Things is a network of the physical objects embedded with sensors, electrical devices, electronics, and connectivity in order to achieve a great value and service by exchanging the data to the manufacturer, connected devices, and operator. And each device, each thing is uniquely identifiable because of the embedded computing, and it enables internet connection. It interoperate with the existing internet infrastructure. We are going to study about the characteristic of IoT, and the first one is dynamic and self-adapting. So the first one is dynamic and self-adapting. If you look onto a camera, surveillance camera, in the morning it will be having a normal mode, and on the night it will be having IR mode of surveillance. And at night the camera need to switch from a low resolution to high resolution mode likewise. And if there is something happening, they need to tell other cameras to be alert. So depending on the changing of the conditions, changing of the sensed environments, they have to make changes. they have to adapt with changes, right? So IoT devices and systems may have the capability, IoT devices and systems have the capability to dynamically adapt, okay, with the changing context. With the changing context, it has to dynamically adapt to those changing context and take actions based on the operating condition, user context, and the third one is sensed environment. So what I've just said is dynamic and self-adapting is a characteristic of IoT where it adapt and it is dynamically adapt to the condition, to the changing context, and take actions based on that changing environment, sensed environments. Okay, so dynamically adapt those changing environment, changing context, and pravartikika, that is take actions based on those operating conditions, user context, and sensed environment. Okay, the next is IoT have self-configuring characteristic. That means IoT devices may have self-configuring capability, allowing a large number of devices to work together to provide certain functionality. If we take an example of a CCTV camera, so we have about 10 CCTV cameras and they automatically configures with a special type of network, and if we add 5 more CCTV cameras, it will automatically self-configure itself. So it will become 15 CCTV cameras in total. So as because of this self-configuring characteristic, allowing a large number of devices to work together to provide certain functionality. Okay, they all allowing a large number of devices to work together, providing them a functionality. IoT devices may have the self-configuring capability. IoT devices have the self-configuring capability that allows a large number of devices to work together to provide a certain functionality. Okay. IoT devices are able to upgrade their software in accordance with requirements with minimum of user participation. So if you take an example, that CCTV camera, the manufacturer is doing some update on that CCTV camera, and what happened is if we will get only a small notification that the installation was done successfully. So this is because of upgrading the software with minimum user participation. Okay, IoT devices are able to upgrade their software by minimum user participation. So like this, what happened is it allows a large number of networks, large number of devices to provide to work together to provide a certain functionality. The addition of new devices, as because they can set up the network, as because they can set up the network alone, they can add new devices to an already existing network. That is why it is known as self-configuring. So the next characteristic is interoperable communication protocol. Let's assume that your fridge is of Samsung and your mixie is of Philips. What happened? Even though they are from different manufacturers, we need to communicate, and for that communication we have separate communication protocols, and these refers to the ability of a different IoT system devices and systems to communicate and exchange data with each other, irrespective of the manufacturer or regardless of the underlying technology of the manufacturer. They can communicate through the interoperable communication protocols, and here in the green letters it is shown as Bluetooth and IP version 6. The next is unique identity. In order to track a particular entity, what you have to do is you need to have some unique identifier and unique identity, like URI, that is uniform resource identifier or IP address. So likewise, using a unique identity, we will identify the device. Next is integrated into information network. That means IoT devices are usually integrated into the information network that allows them to communicate and exchange data with other devices and systems. That means They integrate into an information network, and they allow them to communicate and exchange data with other devices and system. മറ്റ് ഡിവൈസസിലോ സിസ്റ്റത്തിലോ ഒക്കെ നമുക്ക് കമ്മ്യൂണിക്കേറ്റ് ചെയ്ത് എക്സ്ചേഞ്ച് ഡേറ്റ ചെയ്യാൻ പറ്റും. So IoT devices are usually integrated into information network ആയിട്ട് ഇൻറ്റഗ്രേറ്റ് ചെയ്യും, എന്നിട്ട് അത് കമ്മ്യൂണിക്കേറ്റ് ചെയ്യും ടു എക്സ്ചേഞ്ച് ഡേറ്റ വിത്ത് അതർ ഡിവൈസ് ആൻഡ് സിസ്റ്റം. അതായത് ഒരു 1000 വെതർ ഡേറ്റ ഉണ്ടെന്ന് വിചാരിച്ചാൽ they all collect from different sensors and give it to a data center, and our data center ആണെങ്കിൽ analyze ചെയ്യും the predictions and it will give the last useful predictions. And അതാണ് പറയുന്നത് integrate into information network, okay, that allows them to communicate, then exchange data to the other devices and systems. Okay, data from the large number of connected weather monitoring IoT nodes can be aggregated and analyzed to predict the weather. So that is from different connected weather monitoring systems we will get the data, and these data are used to analyze, and it is used to predict the weather. And these nodes, typically equipped with sensors, can monitor various weather parameters like temperature, humidity, wind speed, and rainfall, and then transmit this data to a central system for analysis and dissemination. That means these nodes, typically equipped with sensors and can monitor various weather parameters like temperature, humidity, wind speed, rainfall. They using these sensors, they will sense all these things and then transmit this data, that is temperature, humidity, wind speed, rainfall, every data is transmitted to this data to a central system. So there is a central system which transmit all these data to a central system for analysis, and after analyzing there will be a dissemination. Okay, that means it transmit the useful data to others, so it is integrated into information network. So we have learned about 5 characteristics and the definition of IoT. So 5 characteristics was dynamic and self-adapting. I've told they are dynamically adapt to the sensed environments, and the self-confident I told that is it allows addition of the new devices. That means I've told that it allows a large number of physical devices to functionally operate together, work together to provide the certain functionality. And I told about the interoperable communication protocols. Even though they're of different systems, they can communicate using the protocols, and they have unique identity, I've told, and they're integrated into information network. Okay, so they all integrated into a information network. So we have learned 5 characteristics of IoT and what it means by integrated into information network